So when x is 0, y is 0, and the curve would probably go like, not like that. Somewhere. When x is 2, the value of y is 16. So I have given you the bounds. The bounds is from 0 to 2. And we are going to spin it about the y-axis. So when we put the strip, should it be vertical? Should it be horizontal? About the y-axis. Vertical. Vertical, okay. So dx. The other parts are easy. We've got 2 pi r h. R is the radius, h is the height of what? Radius of the cylinder, height of the cylinder. Okay. What are the limits? Zero to 2, because the limits are for x. Okay. Now the strip is vertical, and the first cylinder that we put, perhaps, you know, something like that. Yes. One is on the left-hand side, right-hand side. This would be the reflection. If you want, you can draw it. It's not necessary. The next cylinder will also have a height. Let's put a strip up there. And good. So the height of the cylinder is going to vary. It is going to vary with respect to the curve. The radius will also change. What is the radius in this case, since the strip is vertical? If I pick an arbitrary x, right? The radius here would be x. Agreed. If I picked an arbitrary x1, the radius there would be x1. Agreed. So radius simply would be x. Yes, no, maybe. Okay, now that's fine. What about the height? Let's just draw one more. That is my strip at some position x. That is going to give my thickness. But I would like to know the height of the cylinder that is going to pull up.
It's the function.
Alex says it is the function. Do we agree? Caleb doesn't agree with you. He's objecting. Why not, Caleb?
There's a constant height of 16.
It's a constant height of 16. Well, that is the maximum value that you get to, right? Is that what you're trying to say? But you are correct. You are going in the right direction. So first hint Alex, there is a constant height of 16. He's just not phrasing it in the right way. Raphael.
That's of x.
Well, that's what Alex said, and Caleb objected, rightfully so. It's not f of x. How about this? If the height is f of x, good. Right here, the height is 16. Do you agree? Okay. Let's just say this number right there is x1 equals 1. Good. Plug it in the function. 2 times 1 cubed, 2. So that would be 1, 2. Yes. So that's the height. Agreed. And let's move on there. Let's say x is 3 over 4. Plug it in the function. 3 over 4 cubed, 27 over 64, and then I'll have 2. So 27 over 32. So at that point right there, y is 27 over 32. Point 8 something. Good. But is that the height we want for our cylinder? Michael, number 1, says no. Why not, Michael?
Because it's not the maximum height you can get.
Can't hear you.
It's not the maximum height you can get with the.
It is not the maximum height you can get. Okay. So I'm spinning this curve about this axis. Yes. And that is the region that I'm focused in. Agreed. And whatever volume I generate must correspond to that part. Agreed. Which means that shouldn't be there. Agreed. I don't want that. Caleb gave us the hint. There is a height of 16.
Let's say like 16 minus, it's not f of x, right?
Well, you tell me.
16 minus x. Well,
Right?
I was gonna say, I was gonna ask for the 16 minus function.
Very good. 16 minus the function. So let's use that logic here. Alex looked at this height, right? Which is this part right here. So over there, I have 1 comma f of 1. Over there, it's 3 over 4, comma f of 3 over 4. And the last height is 2, comma f of 2. Yes? The outside part right here is traced by the function. And what we want is that height, that tiny height, that height that is inside the function. Good? Well, logic from, I guess, Water method revolving about an axis that is not x or y. If you know the maximum height is 16, yes, and you know that the curve traces some part and its height is f of x. Yes. What should go in the middle? Total is 16. This part is f of x. What is that part? Michael.
16 minus f of x.
16 minus f of x. Correct. Add those two together, you get the full length of 16. Good. But what is f of x? It's just y. So the height is 16 minus 2x cubed dx. 2 pi integral 0 to 2, 16x minus 2x raised 4 dx. 2 pi 0, well, you can split the integral 16x squared over 2 minus 2 x raised 5 over 5. You're just integrating. Lower limit, nobody cares. It's going to be 0. Upper limit, 2 pi 64 over 2 minus 64 over 5. 3 times 64 over 10. $192 pi over 5. Times over here 16 times 4, 64. Upper limit 2 raised 5, 32, 32 times 2, 64. Common denominator 5 times 64 minus 3 times 64. I guess I did bad math. There should be 2 times 64. Yes, 128 pi over 5. Oh,
I got 228.
228. Oh,
I got 192.
192 is the correct answer. I had it right, my bad. How'd you get 228? So this is 5 times 64. We take the common denominator. Minus 2 times 64, which should be 3 times 64.
Well, I simplified it on top. This is
This one?
no, it's not. Second. Oh, here. Yeah, it's 6.
You did it as 8x squared. That shouldn't make a huge difference. Maybe you made a mistake in combining stuff. Okay. The answer I had beginning was correct. But do we follow? So you've got to think just a bit extra, but the traces itself is easier compared to washing it.
How would the question be written if we wanted to take the value that's like beneath the curves and with the x-axis?
Great question. So let's say you want to find the volume below this curve. You are spinning it about the x-axis. And you want to use a method of cylindrical shells. Good?
No, like about the y-axis, like if we wanted like kind of like the bowl shape, how would the question be written? You know that we have to find the area under. Or,
Oh, so if it's the area under this.
yeah, but revolved around the y-axis. Because I started solving it just like the height would be 2x cubed.
Right.
I think she's saying because they're both enclosed, right? Both
Right.
areas, so.
So how would we define it if it is right here?
Yeah, so.
You would add another statement that x is equal to 0, right? Sorry, y equals 0, which would be this axis. So that will tell you, okay, I've got to include this part also. If I throw in y equals 0, so I want this constraint, that constraint. So I need both of them.
So it would be
Comma y equals 0. So there should be another y equals 0.
so because like the majority is on the y-axis, that's why it's that one.
Yeah, so when I see your question, if I added this, then do that part.
Okay.
Right? Because I'm putting the axis over here. Good? Okay. Are we clear? Erase. This thing should be this is not much function. Square. Just for you. Greater than or equal to 0 and do about x axis. Bounded by y just 1. Okay, can't stress enough, you've got to draw the picture and draw it properly. Just because you did 16 minus f of x doesn't mean you're going to do the same thing here. You've got to follow logic. You drew it in the calculator, right? And you graphed it. It looked like does. Agreed. Yes. The reason why I'm stopping right there is because I have 0 as one of the constraints. The maximum value that I can go up here is 1. Yes. And I'm drawing y equals 1 because enclosed area would be the top area minus the bottom area would be right here. Yes? Top curve minus bottom curve. That can't be the enclosed area because it's going all the way up to infinity. You would have infinite volume. Good so far? And if you got this part right, the troubling part or the troublesome part was finding the radius and the height. Okay. 2 pi. Always there. Agreed. Radius, height. But before we get to that, we've got to decide the thickness component. Is it going to be in terms of x or is it going to be in terms of y? Well, cylindrical shells, it's the opposite. If you revolve around x-axis, it will be d1. Good. The next step is to resolve the bounds. Well, y can only go from 0 up to 1. Agreed. 0, 1. Now we have to find the radius followed by the height. Is the shell going to be vertical or horizontal? Horizontal. Okay. My first one, right? I'll draw one more for reference. Since this is the enclosed area, my shells need to stop, right? They must stop there, correct? I can't put a cylinder past that point. So my fully drawn cylinder, half cylinder, whatever. If this is half, I always draw a mirror image. What is the height and what is the radius? If I pick an arbitrary y, we'll call it y1 so that we don't confuse ourselves. y1, I drop it down, I get an x1. Yes? If I pick an arbitrary y2, I get the corresponding x2. Agreed. The blue strip was height of the first shell. X1. The purple strip is the height of the second shell. Good. So here it was x1, there x2. So if it's an arbitrary x, you will just have 1, x1. Okay, so the height is simply some x. Good. I'm just going to put x. Why can I not sorry, I take that back. These x's are changing. In other words, the height is going to change with respect to that curve. So we've got to do something there. We'll get to that. The radius part is easy. First case, it was y1. Next case, it was just y2. Right? So no matter what x value you pick, the height is simply defined by y. So y we can't simply get rid of that x, but I do know everything else is set up properly. I have an integral in terms of y, balance in terms of y, can't just throw away x. We know that that height is tracing this function, and it's simply x, right? Somehow I've got to rewrite that integral fully in terms of y. Is it doable? Yes. Original problem. Y is square root of 1 minus x squared. Square on both sides. Y squared equals 1 minus x squared. Move x squared to the other side, y squared to this side. You would have x squared equals 1 minus y squared. We can solve for x, agreed. This would simply mean x is square root of 1 minus y squared. With me so far? Now, back over here. 2 pi integral 0 to 1 y multiplied by square root of 1 minus y squared dy. How do we integrate that? Arthur, use substitution. Forgotten everything. You know the exams next week. U is 1 minus y squared. Sure, you could have it in a different way, but I'm just going to go for u equals 1 minus y squared. Du divided by dy equals 1 minus, sorry, bad math. Derivative of 1 is 0, I get minus 2y. Do I have the other part in the integral? Yes, I have y dy. All I have to do is solve for y dy. So divide by -2 on both sides. Negative du over 2 equals y times dy. Good. I am not going to go over use substitution. You should know that by now. You should know that by now. Never mind. Square root of u The leftover part, y dy is simply negative du divided by 2. Good. Did we take an integral that was fully in terms of y, converted to an integral in terms of u? Yes, okay. Some would like to carry the limit to the very last step. I don't. I like to change it right away. So when y is 0, u is 1. When y is 1, u is 0. Perfectly fine. Erase. Two pi integral 1 to 0 negative square root of u du divided by 2. Good. 2's will go away. Negative pi integral 1 to 0 square root of u du. I'm still doing that negative for a reason. Property of integration. I want to get rid of that negativity. What can I do? Michael?
Change it from 0 to 1.
Flip the limits. When you flip the limits, then sign is going to go away. So pi 0 to 1 square root of u du. Anytime you see a root of some sort, what is the first thing that you should do? Raise it to a fractional exponent. In this case, it is u raised 1/2 du. Integral of that 2 pi over 3 u raised 3 over 2. Lower limit, it's going to go away. Upper limit, 1 raised 3 over 2 is just 1. You have 2 pi divided by 3. Good. That's the final answer. Well, we did all this work. But I knew the answer from the very first step. Should have. I didn't expect you to, but a bit of thinking could have gone a long way. None of this was required in this problem. Had you known geometry, Lorenzo caught it right away. Quarter of a circle, right? We're spinning it around the x-axis. What do you get? No, it's simply put, you have, a section and you are spinning it. What do you get? Half of a sphere, right? What is the radius of the sphere? The radius is 1. The volume of a sphere is 4/3 pi r cubed. If I'm looking at the full volume, the answer would be 4 pi divided by 3. I'm only looking at half the sphere. So the answer is 2 pi over 3, 1 cubed is just 1. Good. The reason for all of this is so that you can understand that bit. Yes.
Why use substitution instead of like making that to the 1/2?
So in this step, you are suggesting, why can I not do this? Y 1 minus y squared raised 1/2. Nothing wrong with that. Keep going.
Take, you know, what? Yeah.
Yeah, so
Yeah, so I would.
you're saying
I
from
did,
here, you go to your substitution, or
I did 3 times y. Or sorry, y over 2, then that to the 3x. That's it.
y over, what is it?
2.
Oh, I see, so,
There's an integral in front of this, right?
okay,
So-
integral in front of
Why
it.
can't we do that?
Yeah, this is the same as that, I'm just not following what your approach was.
Good. I didn't use u, I just did it.
What was your next step?
My next step made it,
The inside part.
I made it 2/3 y.
Okay, 2/3 y.
Correct. And then the parentheses. 1 minus y squared. 2. That's all. Try it wrong, it's all this.
Do we think what Caleb is trying to say? No, Caleb pretty much did use substitution. If you treat this to be u, then you have u raised 1/2. And from that, you will have 2/3. You shouldn't have that y back there, right? Should not be that. Because once you integrate back here, you look at my answer, I have 2/3. If you replace it with y, I would simply have 1 minus y squared raised 3/2. I will not have y here. Okay, that's why, that's wrong. So, if life was that easy, Caleb, I'd be in a different galaxy. Good. Okay, we will just set this up and pick it up next time. Let's see if we can set it up properly. So volume generated by revolving the area enclosed by y equals 1, y equals sin x, y equals 0, which would be the x-axis, about the line y equals 2. So all I need is the setup for method of cylindrical shells. We can do the integration part later or next time.